Hi folks, and welcome to NahamCon, and also welcome to this talk, which I have titled Blackbox Monitoring for Timely Bug Detection. Now, you might wonder whose voice you're listening to, and you're about to find out. My name is Luke Stevens, and if you follow me online, there's a good chance that you know me as HackLuke. HackLuke doesn't have a C in it. It's HAKLUKE, and that's my username on Twitter and also on YouTube. If you want to find me on Instagram, you've got to put an underscore next to it. But anyway, you can find all of the links on my website, which is hackluke.com. And I am first and foremost a father to my daughter, who is 2 years old, and I've got a son on the way. And of course, also a husband to my gorgeous wife. And I'm an ex-developer and mostly worked with PHP when I was a developer, but also worked pretty extensively with Python and now almost exclusively Golang recently for developing a bunch of hacking tools, which you can find on my GitHub. I'm an ex-pen tester, so I was pen testing mostly web applications, but also internal networks, external networks, kiosks, all kinds of different things that, had a lot of fun doing that for a few years. And also I was a manager at Bugcrowd. I basically trained up and managed a team of triagers at Bugcrowd, which was a crazy, awesome experience. Got to work with a lot of cool people on a lot of cool projects. And of course, I was into bug bounties too. In fact, I was actually really into bug bounties as a bug bounty hunter well before I worked at Bugcrowd. And that's kind of how I got into Bugcrowd. And then still do bug bounties from time to time now. Definitely have a big passion for it still and everything. But it's hard to find the time for it, to be honest, because I'm also running my own penetration testing and security consultancy. So doing a lot of security work with different organizations, advising them on how to be more secure, pretty much, and also doing a lot of kind of application security stuff and secure development training and compliance stuff. So if you have anything like that you need, don't hesitate to get in touch. And also about maybe 6 months ago, something like that, I started this project called hackercontent.com. I basically noticed that there are a whole bunch of cybersecurity creators who create this awesome cybersecurity content. And there are also a bunch of cybersecurity organizations who are really struggling to get good cybersecurity content for their content marketing and also, on their social media profiles and things like that. So I basically created hackercontent.com, which merges those two together and allows basically cybersecurity organizations, penetration testing firms, vendors, whatever, to have really high quality cybersecurity content on their website. So if you're after that, go to hackercontent.com. And also, if you like writing cybersecurity blogs and things like that, and you feel like you're really good at it, really proficient at that, also go to hackercontent.com and you can sign up as a creator. So the last facts that you need to know about me, definitely a fact, cold hard fact, is that I invented Bitcoin. So just call me Satoshi. So here's a brief history of bug bounty automation, okay? At the start, when I first got into bug bounty automation, it was easy money. And that is kind of one of the things that kind of attracted me to it, I suppose. So a bunch of hunters, well, actually it was only a really small group of hunters at the start, developed kind of private automation. Wasn't open source or anything like that initially. And it would basically perform reconnaissance and vulnerability scanning, and it would discover like low-hanging vulnerabilities at scale. And that proved to be like a really kind of profitable method. And that's why like more and more people started getting into it until eventually Nuclei was released, which was, if you don't know Nuclei, it's if you just Google project discovery nuclei, it will come up. But basically, it's a tool that is designed for vulnerability scanning, and you can give it custom YAML files, like templates that will define exactly what needs to be looked for and what type of requests need to be sent and things like that. So this changed the game, right, when this tool was released, because suddenly everyone had pretty decent automation and vulnerability scanning capabilities just with this tool. I don't think it was a bad thing for the internet in general. I think, like, you know, a lot of companies became a lot more secure when this type of tool is released to all of the bug bounty hunters in the world for free. But it did mean that as a bug bounty hunter who focused a lot on automation at the time, competition increased dramatically after that, and it's increased more and more and more as the years have gone on. There's another thing that happened too. Attack surface management started becoming a thing, and I think that was mostly actually due to bug bounty programs realizing that they didn't actually have very good visibility over their external facing assets when bug bounty hunters started discovering them and finding vulnerabilities in them. So attack surface management basically became quite popular, especially in like larger organizations. And everyone kind of, well, not everyone, but particularly large organizations started rolling out more comprehensive attack surface management programs, which helped them to monitor their own systems. And then all of a sudden, scanning for low-hanging fruit in this kind of way, using solely bug bounty automation stuff, suddenly kind of became pretty unprofitable, at least for me, but I think for a lot of other hackers as well. And so a lot of the top hackers kind of started pivoting to other methods of making money through bug bounties. And there are also a lot of people who didn't pivot, but of course, what happens now is they haven't pivoted. They're still using like default nuclei templates, but everyone's using the same templates, and everyone's just finding duplicates, and in the process they're sending heaps and heaps of traffic on every host that they scan. They're frustrating program owners and they're frustrating triages. So don't do this. Now, there's a common thing that happens where people go, oh, nuclei. Oh, that tool is to blame. But I want to be really clear about this. I'm not blaming nuclei, and I don't think anyone should blame nuclei. Nuclei is an awesome tool, and I use it all the time. The problem is that people are using nuclei lazily. They're just loading up the default nuclei templates, and then they're just throwing them at like bug bounty targets that have already been tested in exactly the same way thousands of times by other people already. So it could be that they are just lazy, or it could be that they just don't know a better way yet. So they've heard about this nuclei tool and they just thought that, okay, I'll use all the templates, might as well. And they haven't really figured out how to use it in a way that is kind of going to get them good results on bug bounty programs in 2022. So kind of start thinking, like, when you start looking at the history of bug bounty automation, and you kind of get to this stalemate now where it's not really profitable anymore. So begs the question, what's next? Is automation useful at all anymore, or are we just looking more at deep dives now? Anyway, if automation is still useful, how could we use it? How could it help us most effectively? And there was this concept of there being kind of two streams of hackers, right? There's the people who focus exclusively on automation, and the people who focus exclusively on manual hacking or deep dives or whatever you want to call it. Is this the right way to go? Do you just pick one of those streams and go in? Do you ditch automation now because it's not useful and go the manual hacking route? No, you don't do that. Then there's this other kind of mental model that I kind of started thinking, and also I've seen other people talk about it, and we talk about switching. There's this kind of sliding scale that goes between manual hacking and automation, and every hacker kind of sits somewhere on that scale. So are they completely manual, or do they use a bit of automation or anything? But you know what? I feel like this is just too simple as well, and I don't think it really properly summarizes how you can effectively use automation now. So let's get rid of that one too, shall we? Get rid of it, put a big red cross on it. The next one, and this is a term that I totally made up, and I'm sorry that it is a stupid name that really doesn't say a whole lot about it. But anyway, it's task-based hybrid. Okay, this is the name I came up with for it. But it's not a new concept. I just slapped a name on it and called it my own. So this is basically what I'm referring to is we're using automation to augment our manual hacking. And, this is kind of what people have been doing for a really long time already, right? For example, we're using Burp Suite. We find an IDOR that we want to exploit. We chuck it into Intruder, and we run it over like thousands and thousands of numbers, and we get all of the, whatever we're downloading with the IDOR. That's automation, right? But I think we can take it a whole lot further when we combine it with recon and stuff like that. So task-based hybrid. Okay. So more specifically, how this task-based hybrid system would work is we basically create a solution where we're using automation to prioritize where our human intelligence is focused. So this can be done in a whole bunch of different ways, but first, we're going to talk about what the automation would provide in this type of model. So think about it this way. The human mind is only good at focusing on like one thing at a time. If we wanted to scan 1 million hosts or 1 million web servers, say, and we had to download the HTTP response from every one of those web servers and manually inspect it, that would take us way too long. Whereas automation can do that very, very quickly, right? So that is one contrived example of where automation might be used over a human brain, human intelligence, because it's just better at that task. So when I talk about task-based hybrid approach, I'm basically saying that we use automation for the things that automation is good for, and we use our brains for things that our brains are good for. So what is automation good at? Well, scale. We can apply automation at scale, which is obviously extremely helpful. Continuity is a good one. So, computers don't need to sleep. They can just continuously over and over and over again perform the same tasks. Menial recon tasks. So, for example, querying an API like security trails, for example, for subdomains. We don't need to do that manually. We could get automation to do that all of the time. Sorry. Another one is gathering risk markers, and we're going to talk more about risk markers a little bit later. So don't worry about that for now. Prioritization, which we're also going to talk about later. But basically what I'm referring to there is prioritizing hosts based on how risky they are, so that we could just pick the one that looks the most risky and kind of take a look at that manually. And also automation is good at change tracking. Okay. So the way I see it, there are basically 3 categories that automation is good at when it comes to bug bounty automation. Freshness is one of them. Changes is another one, and risk markers. So they're detecting these 3 things in the model that I'm kind of referring to. They're detecting freshness, changes, and risk markers, and we'll go through what each of those means. So freshness is well, there are many ways in which a target can be fresh. I think this is best explained through example. A new program launches, the targets in that program are fresh. They have been untouched by other bug bounty hunters. New scope is added, another example. New subdomain pops up. For example, if you're constantly monitoring for new subdomains and one pops up, that subdomain is fresh, hasn't been touched before because it's only just come online. A company acquires another company. Well, that acquisition is fresh, hasn't been hacked before. You have to obviously make sure that company acquisitions are in scope. And there actually aren't many bug bounty programs that allow this, but there are some. New functionality pops up. New endpoints pop up. There are changes to a JavaScript file. That's something you could detect with automation. new technologies are utilized, so say you're running something like Wapalizer against a target, well, you can do that over and over and over again every hour for the next 10 years. And whenever a new technology is utilized, you could take a look at that. DNS record changes, obviously great one to detect with automation. If there's any DNS record change, it's probably something that might be good to review manually to see if a vulnerability is detected. These are all things that, at scale, you could do quite easily with automation. The next kind of category, and this kind of overlaps with Freshness, but it's not the same thing. So when I'm talking about detecting Freshness, I'm talking about detecting like mostly new targets that are popping up. Whereas changes, I'm talking about detecting changes to existing targets. So some examples of how you might do this are monitoring 403 responses. And if they ever change to a 200 response, you might want to have a look at that because it might be showing something sensitive that's meant to still be forbidden. You might want to monitor suspicious looking subdomains that are not returning anything yet. For example, this is another contrived example, but adminpanel.paypal.com. If that was returning a blank page for 5 years straight, and then all of a sudden it was returning a web app, that's definitely something that I would want to take a look at. If you maybe are crawling all of the web applications that you're discovering, and all of a sudden your crawler discovers a new endpoint, you might want to check out that endpoint. There's an edge that I don't think many bug bounty hunters are currently doing. You could run tech detection daily, so something like Wapalizer, like we already talked about. And when a new technology pops up, you could check that. That's a nice change. And also, really basic one, you could just monitor an HTTP response, and when it changes, you check it manually. You've got to be careful with this one because a lot of HTTP responses will change every single time the page is loaded because there'll be like a nonce or something in the page. So you can't just do like a byte for byte, comparison of the two. You have to kind of tokenize the page or do it based on like a percentage of change or something like that. Now, there's this concept that basically I don't know if other people call it risk markers. I think I may have just like made this term up, but definitely I'm borrowing it from medical terms. They talk about risk markers in blood and things like that. So you might have a risk marker for a particular genetic disease or something like that. But when I talk about risk markers here, obviously I'm not talking about blood. I'm talking about things like this. So you might send a request to a web application and it comes back and at the bottom of the page it says copyright 1995. In that case, alarm bells should be ringing because that is an extremely old web page. And you might want to take a look at that. And I don't think you're going to see 1995 very often, but maybe like copyright 2008. That would be something that I would still want to check out because it's there's a good chance that it's running some old stuff. Same with server Apache 2.2. That's a very old version of Apache. And something like that, if I saw it in an HTTP header response, I would immediately go, wow, this is old. There's a lot of old stuff here. There's probably something vulnerable. Expired SSL certificate is a risk marker because it kind of indicates that the security team at that organization is maybe not aware of that host or doesn't care about it enough maybe to renew the SSL certificate. You might have some kind of some word in a host name that indicates that it might be sensitive. I put internal here, which may be good as an indicator. Shodan does this cool thing where you can give it an IP address and it will give back any CVEs that Shodan thinks that IP address is vulnerable to. So if a particular IP address has lots of CVEs returned by Shodan, there's a good chance that it's old. So I use that one. And also nuclei. You can pick some specific nuclei templates that might discover older technologies or imply that they're in use. So that's a really good way to kind of discover hosts that that maybe are worth looking at.
I'm not sure I understand.
Oh, my watch is talking to me. Siri doesn't understand. I hope you guys understand. And then, so we've talked about all the things that automation provides. So then what does the human provide? Well, the human provides intelligence and manual hacking. Okay. So that's basically it. So when we marry these two things, we marry the automation with the human, we get the best of both worlds. And that's what we're after. So here's what the whole process would look like. We've talked a lot about all the different stuff in different pieces, but this is basically what the process would look like for a task-based hybrid approach. The process, basically, the first thing that would happen is the automation performs reconnaissance, and it does that continuously over and over and over again. After it does the reconnaissance, it can start over and over again, also uncovering vulnerabilities and risk markers. And then as it starts uncovering those, it can start basically developing some kind of risk scores for each host that you discover, or each asset that you discover. And then once it has these risk scores, it can easily order them. So it's prioritizing hosts based on how likely they are to be vulnerable by analyzing their risk markers. And then it can also track changes, that the automation can track changes and freshness. And all of that is just going 24/7. So there'll be maybe separate systems, but they all kind of talk to each other. And the automation will be doing reconnaissance, prioritization, finding risk markers, tracking changes, and maybe even like monitoring bug bounty platforms for new targets popping up and things like that. And then all a human has to do is review the changes that are discovered by the automation, and also hack on the hosts that have the highest risk markers, because those are the hosts that hopefully are the most likely to be vulnerable. And that is how we can basically focus our human intelligence, which is like a single track kind of non-scalable system. And that's how we can focus that human intelligence, by using automation to kind of guide where we should be looking. The end result is that you can use the process to increase your chance of success in bug bounties by channeling your human intelligence where it is most needed. So I hope you enjoyed the talk today. Thank you so much for being here, but especially thank you to the organizers and the sponsors of today's event. And thank you to NahamSec for inviting me to be here at this awesome conference. Really, really, really a privilege to be here. So thank you. And most of all, perhaps thank you to the people watching the conference, because, it wouldn't be much of a conference if there was nobody watching. So thank you so much. And I hope you all have a great day. Hope you all enjoy the rest of the conference. And I'll catch you all around the internet somewhere. Bye.